For problem 34, if f is a continuous even function such that the integral from 0 to 3 of f of x dx is equal to -4, then what is the integral from -3 to 3 of 5 times f of x plus 1 dx? So in order to evaluate this particular integral, we first need to understand what even functions are and their properties. So the most basic feature of an even function, let's say the function y equals x squared, since this is probably the simplest even function, the most basic feature is that even functions are symmetric about the y-axis. So if I were to draw a rough picture of this parabola here, y equals x squared, we can see that this is symmetric about the y-axis here. So if I were to take an integral from, let's say, minus a to a in a function, so writing that integral, minus a to a of x squared dx, this is essentially asking us what is the area underneath the curve from minus a to a. And if my drawing were a little bit more accurate, you would see that these areas from minus a to 0 and from 0 to a are equal to each other. So this area here and this area here. And that's going to be a common feature of even functions. So we could rewrite this integral as twice the integral from 0 to a of x squared dx. Since, like I said, this area here and this area here are equal to each other, so we can essentially just find the area of 1 and double it. So let's first make some space and then apply this idea to the integral we have to evaluate. And one of the first things you can notice about this integral is that we have a sum inside the integral. So if you have the integral of a sum, you can break that up into the sum of multiple integrals. So in other words, we can rewrite this as the integral from -3 to 3 of this first term of the sum, which is 5 times f of x. And then we have plus a second integral from -3 to 3 of the second term of the sum, which is just 1 dx. And since we have a constant inside the integral, we can actually factor that out so that we have 5 times this integral here. And recalling what I mentioned about even functions, this integral here can essentially be rewritten as 5. This constant here just carries along. And then we have twice the integral from 0 to 3 of f of x dx. And I forgot my dx here. And then this integral can evaluate to just x, since the integral of 1 dx is just x. And we have to evaluate that from -3 to 3. So simplifying everything, we have 10 times this integral from 0 to 3 of f of x dx. And then this integral has been evaluated. We'll just plug in the 3 first and then subtract off this lower bound where -3 is plugged in. And what we can notice about this integral here is that we were told what it's equal to in the problem. So that integral from 0 to 3 of f of x dx is just -4. So let's make a substitution now. For this integral, this is just -4, so we have 10 times -4, and then plus 3 minus -3, but if we're subtracting a negative, that's the same thing as adding. So we have plus 6 here, so -40 plus 6 simplifies to -34. So this integral here evaluates to -34.